Hi, welcome to Math for All, where everyone can learn more about math. Today, we will continue our adventure with square roots by learning how to simplify them. We will explore what that means and then go through some steps to get that done every time with numbers and variables. Let's go get this. We must simplify radicals much like we simplify or reduce fractions. A square root is simplified when there are no perfect squares under the radical sign. Like in the square root of 12, it is the square root of 4 times 3, and 4 is a perfect square, so he comes out. We don't pull out a 4, rather the square root of 4, which is 2. 2 goes in front, the 3 stays inside for an answer read as 2 times the square root of 3, often shortened as 2 root 3. Now that you see what we're trying to achieve, we're going to go through some steps so we don't have to search high and low for perfect squares. We will use factor trees as a tool for this, but never fear. If it's been a bit since you've seen those, we will do a nice review so they will be as easy as pie. First, let's review our prime numbers under 20. These are numbers that are only divisible by themselves and 1, but not including 1. Here's the list: 2, 3, 5, 7, 11, 13, 17, and 19. We want to remember these because once they're in our factor trees, we know we are done. Here it goes in action. Simplify the square root of 72. Step 1. Break 72 into its prime factors. I like to make 2 little branches like this, and I put the numbers that multiply to equal 72. Any numbers that multiply to 72 will work, except for 1 and 72. I'll choose 9 and 8 because I do remember that multiplication fact. Since neither of those are prime, we keep going. 9 is 3 times 3, and 8 is 4 times 2. Now, we just take care of the 4, and he turns into 2 times 2. Now, that 72 is all broken up into his prime numbers. Step 2. Circle groups of 2 of the same primes. For us, we have 2 2s here and 2 3s here. I recommend underlining any primes that are not in any groups, like this lonely 2 over here. Step 3. Take out the perfect squares. We'll do that by pulling out one of the numbers in any of the circled groups. We have a 2 and a 3, and you multiply those together, and so you put a 6 in the front. Step 4. Leave any singles inside the square root. We have the leftover 2 who's stuck inside for a final answer of 6 root 2. Here's another example to solidify the process. Simplify the square root of 48. We start with our factor tree. 48 breaks into 6 times 8. 6 is 2 times 3, and 8 is 4 times 2. Keep going with that 4, which is 2 times 2. Now we go searching for duplicates. I see a group of 2s and another group of 2s with a leftover 3. I pull out a 2 from each circle and multiply them for a 4 on the outside, the radical sign, and the leftover 3 inside, 4 root 3. Remember, there's an invisible multiplication between the number and the radical sign. As promised, let's investigate simplifying variables underneath the radical sign. Simplify the square root of x to the 5th. I'll show you the long way and then a shortcut, and you get to pick your favorite method. The long way is to write out x to the 5th into its factors. It's just x multiplied 5 times. Remember circling groups of 2 in our factor trees? That's what we'll do here. A group of 2, another group of 2 with a leftover x. So we pull out 2 x's because of the 2 groups, for x squared on the outside with the x left inside. X squared times the square root of x. Are you ready for the shortcut on simplifying variables? Simplify the square root of b to the 6th. Take the exponent of 6 and we divide it by 2 because we're looking for groups of 2. You get 3, which tells you the exponent of what's pulled out, for an answer of b cubed. If there was a remainder, that is what is left inside the radical. Woohoo! You made it to learn about simplifying square roots, including numbers and variables. When you're ready, come back soon to keep learning more about math.